In this lesson, we learn about EtherChannel load distribution. Let's pay attention to this network diagram. In this network, we have just configured Ether channels on the switches like this. In this lesson, we will log into HPC and ping other PCs for the switches to build MAC address tables. After that, we will check the MAC address table on IT LifeSkill switch 1. Then we analyze its frame forwarding decision using hash algorithm when forwarding frames via an Ether channel. Then we will learn how hash algorithm works with some examples. After that, we will configure port channel load balance on IT LifeSkill switch 1 and verify our configuration. Finally, you are assigned to read the keynotes. To check MAC address table at the switch privilege mode, we need to issue the command show MAC address dash table, then hit enter. Let's do it on IT LifeSkill switch 1. Here we are at the privilege mode. We need to issue the command show MAC address dash table, then hit enter. And here is a current MAC address table on IT LifeSkill switch 1. Now let's analyze the frame forwarding decision on IT LifeSkill switch 1. From the MAC address table, we can see that any frames destined to PC4 will be forwarded via the port E10, and any frames destined to PC7 will be forwarded via the port Ether channel PO1, which means for a switch configured with Ether channel, the frame forwarding decision is to use port channel, not the physical ports bundle in the channel. We know that the port channel is a logical port. In this case, the port channel PO1 contains two physical ports, E01 and E03, and the frames must be forwarded via a physical port. Therefore, there must be a method to figure out which physical port the switch will use to forward frames. This method is called load distribution or load balance, and its detail is given in this table. The table lists all load balance methods with their hash operation to select the physical port to forward frames. Let's assume the caches in PC2 and switch 1 both expired. To send IP packets to PC7, PC2 must send an app request, which is a broadcast frame to find the MAC address of PC7. When the app request reaches switch 1, switch 1 learns the MAC address of PC2 and it floods the broadcast frame to all active ports. The broadcast frame reached PC4 and it will be dropped by PC4 because it's not for PC4. When the broadcast frame reaches the port Ether channel 1, the switch will use one of the load balancing methods in this table configured on switch 1 to select one of the links over here. Let's assume the port E01 is selected. So switch 1 forwards the broadcast frame via the port E01. When the broadcast frame reaches IT Live Skill Switch 2, Switch 2 sees the broadcast frame coming from the port EtherChannel P01, not from the physical port E03. Therefore, Switch 2 will flood the broadcast frame to all active ports except the port P01, which means the frame will never be sent back to the physical port E01, which prevents the loop. The broadcast frame will be dropped by PC5 because this is not for PC5. When the broadcast frame reaches PC7, PC7 will respond with an upreply, which is a unicast frame. IT Live Skill Switch 2 also uses the load balance configured on it to forward the frame via the Ether channel. IT Live Skill Switch 1 and PC2 learns the MAC address of PC7 via the upreply. We will learn more about how hash algorithm works in the next slides to understand how switches select a physical port in an Ether channel to forward frames. In this slide, we will see how the hash algorithm works. First of all, we need to know the IP address, the MAC address, or the port number, and it has to be converted into the binary string. And in this case, I just pick up a random binary string like this. And we also need to know the number of links in Ether channel. This is to decide how many bits will be used in the hash operation. So 2 links or less will require 1 bit. 4 links or less will require 2 bits. 8 links or less will require 3 bits. And in this case, I just pick up 3 bits. So it means in the Ether channel, we must have 5 links or up to 8 links. And based on the load balancing method that we configure on the switch, it will perform the bits operation. The bit operation is performed if only one address or port number is hashed. The switch will forward X frame using by 1 or more low order bits of the hash value as an index into the bundle links. So in this case, the switch will forward to the links number 5 because 2 power 2 equal 4 and 2 power 0 equal 1. So 1 plus 4 equal 5. So links number 5 will be used to forward the frame. Or we can use the sort operation. The sort operation is used if 2 addresses or port numbers are hashed. A switch performs an exclusive or sort operation on 1 or more lower order bits of the addresses or TCP UDP port numbers as an index into the bundle links. So in this case, we pick the same random string and it will perform the sort operation 0 0 0. So link 0 will be used. So I will also include the sort operation in here so that we can figure out. So the sort operation is really easy to remember or to memorize. If the input are the same it will become 0. If the inputs are different, it will become 1. So after that, the links to be used, will be selected. So for the bit operation, the links number 5 will be used. For the sort operation, the links number 0 will be used. And those links are assigned in a round robin fashion. I will talk more about that in the next slides. In this slide, we will talk about the link index assigned by hash algorithm. And you can see in this table, this is the link index from 0 to 7. And if we have only one active link in the EtherChannel, so it's required 1 bit, and after the bit or the sort operation, the value can be either 0 or 1. But because there's only one link, so the link 0 will be used. Now if we have 2 active links, so it's also required 1 bit. But if after the sort or the bit operation, if the value is 0, the link 0 will be used. And if it's the value is 1, the link 1 will be used. If we have 3 active links, so it's required 2 bits. And if the result of the bit or sort operation is 0, 0, link 0 will be used. 0, 1, the link number 1 will be used. 1, 0, link number 2 will be used. But 1, 1, the link number 0 will be used. That's how it's a round robin. Will feel like this. Now if we have 4 links, so after the sort or the bit operation, if the result is 0, 0, link 0 will be used. 0, 1, link 1 will be used. 1, 0, the link number 2 will be used. 1, 1, link number 3 will be used. Now if we have 5 active links, and after the bit or the sort operation, if the result is 0, 0, 0, the link number 0 will be used. 0, 0, 1, the link number 1 will be used. If it's 0, 1, 0, 0, link number 2 will be used. 0, 1, 1, link number 3 will be used. 1, 0, 0, link number 4 will be used. But if it's 1, 0, 1, link number 0 will be used. 1, 1, 0, link number 1 will be used. 1, 1, 1, link number 2 will be used. If it have 6 active links, so it's also require 3 bits. And if the value is 0, 0, link 0 will be used. 0, 0, 1, link number 1 will be used. 0, 1, 0, link number 2 will be used. 0, 1, 1, link number 3 will be used. 1, 1, 1, 0, 0, link number 4 will be used. 1, 0, 1, link number 5 will be used. And 1, 1, 0, link number 0 will be used. 1, 1, 1, link number 1 will be used. and you can figure out for the cases where it has 7 or 8 active links. So as you can see over here, it is better if you have the active links as the power of 2, like 2, 4 and 8. The frame will be distributed evenly. So let's move on to the next slide. In this slide, we will go into the example of how hash algorithm works. In this case, we will analyze the package sent from the IP address 172.22.70.122 to the IP address 172.22.70.127. So this is a source IP address and this is a destination IP address. So let's go into the first case. We use a source IP address as a load balancing method. So it means this will be used to analyze. And in this case, we need to convert 122 into the binary. And we have this binary string. And the number of links in EtherChannel is 2. So it means 1 bit will be used and we use a bits operation. So we have this and we know that the link number 0 will be used. Now move on to the second cases where we use a destination IP address as a load balancing method. So this IP address will be used to analyze, and we have to convert 127 into the binary string, and we have these strings. In this case, the number of links in EtherChannel is 3, so we have 2 bits and we use a bit operation, and here's the result. So 1 it means 3. We convert it into link index 3, but in this case we have 3 links in our EtherChannel index from 0 to 2, so it means the link number 0 will be used. You can go back to the previous table in the previous slide to compare it. Now we're gonna take a look at the third case where we use the source and destination IP address as a load balancing method. So it means we have to use a source IP address and destination IP address to analyze. First, let's take a look at the source IP address, and we need to convert 122 into the binary, and the destination IP address, and we're gonna convert 127 into the binary string. And now we know that in the EtherChannel we have 4 links, so it's required 2 bits for this and for this. And the source operation of 1 and 1 is 0, and 0 1 is make it 1. So the link will be used is link number 1. Now let's analyze the fourth cases where we also still have the
source and destination IP address as a load balancing methods, and we're gonna repeat the same step, convert 122 into binary and convert 127 into binary. But in this case we have 7 links in our ether channels, so it's required 3 bits for the source IP address and 3 bits for the destination, and we're gonna perform the source operation, and we have the result of 101. So it means the link number 5 will be used.
To configure port channel load balance at the switch configuration mode, we need to issue the command port channel load balance. Then we put in a question mark, then hit enter. It will show us with the list of methods that we can configure on that switch. Let's do it on IT Life Skill Switch 1. Here we are at the configuration mode. Let's issue the command port channel load balance, then put in a question mark. And here's a list of options that we can configure for load balance. Let's copy the source destination IP and put it in the command, then hit enter. And that's it. We have just configured the load balance method source destination IP for IT Life Skill Switch 1. To verify which EtherChannel load balance method was configured on a switch, at the switch privilege mode, we need to issue the command show EtherChannel load balance, then hit enter. Let's do it on IT Life Skill Switch 1. Here we are at the privilege mode. We need to issue the command show EtherChannel load balance, then hit enter. As you can see, the current load balance method configured on IT Life Skill Switch 1 is source destination IP. Let's read the keynotes for this lesson. This is the end of this lesson. If you have any questions, please put it in the comment section. Thank you very much for watching.